Without further ado, welcome to GCP, BigQuery, cost reduction demystified. First, a quick disclaimer. I'm not the best in the world of what I do, but I do like what I do so much, so you can challenge me and we can turn everything into a discussion. This is session for fun. There's no commercial no commercial motivation behind it, besides having fun with you guys. It's a community effort, getting to know you. Pedro, if you just can mute yourself. Thank you. Doing it for you. Okay. So just a confirmation, quick confirmation. Can you see my screen?
Yes.
Thank you very much. So in the past, what we did is we had a two-tier architecture. We had an operational DB. We replicated the data and synchronized it to a data warehouse, an API and a web, and everything was quite simple. Then came big data. Everything exploded, so the infrastructure kept breaking every week because of the growth. Then came the cloud that made everything much complicated for everybody. Then came the invoice. So my solution for that is involving cloud methodologies and big data methodologies. Thus, this is data engineering. Just to get a sense of complexity of the AWS stack, you have many technologies that are wrapped around, whether within marketing, whether they are managed or not, or Hadoop oriented or not. It doesn't matter. Each cloud has its own complexity. Even Google has many Hadoop technologies and data solutions. But the beauty of GCP is that they do and try to make everything simple for the end user. In the end of the day, the amount of technologies are staggering. They keep growing. They keep replacing with new and better and faster and cheaper technologies. And it's always a challenge. So the agenda for today is talk about GCP BigQuery cost reduction basics to get a sense of this database, of how you can use it without having to worry about cost reduction too much, because you understand the cost mechanism and what you're built for. This lecture assumes you know a little bit about BigQuery. If not, please let me know. We can do a short discussion and take it from there. We're going to talk about L4 pipelines versus views, and we'll talk about architecture and cost-saving use case using Hadoop for data processing. Okay, so the basics. First of all, to make sure you understand what you are doing, you need to work with a big data architect. Yeah, working with data, especially in the big data use case, an architect is supposed to guide you through the maze of complexity. If you're already working with the big data architecture, educate your team to make sure everybody are in constant communication and everybody know the bits and bytes and the ins and outs of every technology they're using. And make sure you have some training materials. I've prepared for you guys a very detailed BigQuery slides. It's about 100 slides. You can go over it feature by feature from the ground up. The idea in this lecture is to leverage BigQuery to save money and lots of it. Yeah, as a side note, if we talk about the team, I think it's essential to force the team to learn how to work with BigQuery, having costs in mind. As a rule of thumb, since BigQuery is pay-as-you-go service, meaning for every query you run, you pay separately. If you don't run any queries, you pay nothing. It's a serverless service. It's a pay-as-you-go. So as a rule of thumb, people ask me sometimes, what query is too costly? As a rule of thumb, if you pay more than $1 per query, something doesn't make sense. You're doing something wrong. The reason for that, because the pricing is $5 per terabyte processed. This essentially means that if you are spending $1 on your query, you're processing way too much data. Another thing you should know that is a bit different than any other solutions is that import and export are free of charge. Some tips that would save you money. You should avoid doing select star formatting. It's relatively expensive because it brings all the data. Instead of using every column you need, for example, if you have 10 columns and you need only the first and the second column, it will be 20% cheaper to use just the columns you need because BigQuery is a columnar table. Applying a limit on the table, for example, select star from T, limit 10, does not affect the amount of data read, only previewed on the screen. So in terms of the costs, it's counterintuitive to assume that limit will limit your costs. Just so you know, you have a feature called table preview. So you can click it and you're not paying for the preview data. So this can save you money. You have a dry run in the CLI, which will do validations for the query. You can use maximum bytes build setting to limit the cost of a query. You can use table expiration time to remove data. It's no longer needed. For example, after 1 year, you start getting a new day and removing the last day of the year, meaning 366 days ago. Some companies I saw are using streaming inserts, which is nice, but it's additional cost. And sometimes the use case does not imply live updates of the data. So consider working in the batch format. The maximum bill bytes setting is just a amount of bytes you can set that ensure that this query will not exceed the limit of the billing, which is very nice. Furthermore, you can do some quotas per project, per day, per user, that will limit the costs per day. For example, do not go over $10 a day in terms of BigQuery spend. Tips for performance and cost reduction. You can query partition tables. Some of the tables are partitioned, and you can use the pseudo column called partition time. This will essentially cut through the data and only filter the data you need for the specific data range. You can denormalize tables as much as you like because you're only paying for the data you read. So if you have small fact table and several dim tables, when you join them, and you only pay for what you are consuming. If query performance is your top priority, do not use external tables. There are some options to preserve the data, for example, sharded tables, but it becomes more trickier to write the SQL, so I suggest you avoid it. You have some approximate aggregation functions, which are relatively accurate. I don't know why you would do that, because when you want to do aggregation on a number, you usually want an accurate average or aggregation. But you should know that this function exists. It's far less costly and more faster. Order by. When you use functions like order by or window functions, this is a push to the end of the query and flows down everything by an order of magnitude. So you can, if you can avoid an order by, that would be very nice. Avoid repeating joins if you can use it in your query more effectively. That would be great. Any questions before I proceed? Let me check just the chat to see if there's no question from the audience. You can feel free to ask questions in the chat. Okay. Okay, we talked about this. Some more things to avoid. Sometimes you get an error message response too large. You can override it by allowing large result of data sets. If you can avoid self-join, use window functions instead. That would be more efficient. And cross joins, the same. Use GroupBy whenever you can. Data pipelines. So essentially, it's important to understand as data engineer using cloud solutions, the difference between streaming batch and a view. If it's an unused table or it's a small table, consider doing transformation via views. This is essentially let you do in-flight transformation, because of instead of querying the original raw data, you can apply a transformation view on top of it and only query the transformation view. This will essentially make your life easier, but you pay as you go. For every time you run a query, you run the transformation view also. Sometimes you have a recurring heavy query with a business logic. So you should consider doing an ETL pipeline via Reverie or Airflow to save the amount of data scale. For example, if you have a large data set and every day you need to get the aggregation of the data, so you can get a simple ETL job, for example, schedule query or Reverie, to run an aggregation every day once and only analyze the result of the aggregation every day. This will make your invoice cheaper by an order of magnitude. Sometimes there's a complicated use case. For example, the Google Analytics sessions table. It's a table that derived from the Google Analytics API. The structure is highly nested. And I strongly recommend to avoid views because the cost there may be unpredicted. So be sure to flatten the table by batch processing, so it will be easier and simpler. Streaming, as we discussed, only do it if you need the data with low latency, very fresh, very hot, very relevant to the last 1 to 5 minutes. Questions? The impact of Airflow. Airflow is managed, is an orchestration service. There's a managed service called GCP Composer. It easily connects several GCP data services, for example, BigQuery and Dataproc. And since import and export of data is free in BigQuery, sometimes it's easier to export and import the data from GCS and reload everything from scratch instead of doing a complicated data pipeline. Sometimes you can rewrite recurring queries that the costs will be easier. For example, I saw that some jobs are very costly, so I analyzed them. And I saw that if I use Dataproc, I can apply transformation to the data and save up to 50% of the cost. Mind you, it was a very expensive monthly job, a daily job that on the end of the month was almost close to $1,000. So 50% reduction is a $500 reduction on a month-over-month basis. So as discussed, sometimes using Dataproc, which is the Hadoop managed service, can be cheaper on ingestion and transformation use cases. But compared to a modeling aggregations joint, it will be a lot more expensive and compared to BigQuery. So in the end of the day, if you consider simplicity over cost, you should use BigQuery. But if you consider cost reduction, you should consider Dataproc for ingestion and transformation use cases. Another aspect of cost reduction is your architecture. Essentially, a big data architecture, a general one, mind you, is all about 5 layers. The storage layer, ingestion, transformation, modeling, and presentation. What does it mean? Ingestion is a layer in your architecture that is in charge of getting the data from the source to the target. Or the target could be in cloud storage. Then you can apply transformation technologies. For example, if it's a CSV file or JSON file, to switch them to a columnar format. This will essentially make the data much more accessible, much more faster to analyze, and much cheaper to maintain. And in terms of maintenance, it will make your life easier when you write a new modeling job. The modeling layer is any technology you can think of that will join, aggregate, or run machine learning on your data. 1 second, please. Okay. So the bottom line of the slide is that knowing the technology you're going to use is going to save you a lot of money, but also working with correct architecture for your entire data pipeline and data model will also save a lot of money. For example, using flat tables without dimension tables will simplify your life because you have a columnar structure. So if you essentially get all your tables and join them together to one flat, one tools table, you can reduce your cost drastically. Furthermore, if you apply this kind of architecture and apply some thinking on your data model, everything should be faster, cheaper, and simpler. Questions before I proceed? Okay. Summary. The reason we talked about today's lecture is when you work about in the data project, you always have to have a framework in your mind how to evaluate things, how to evaluate the job, how to evaluate the technology. So on the technological aspect, there's a simple framework I created that will help you analyze what you are doing. So it's all about the use case of what you're trying to achieve, but there are some key concepts you should keep in mind. It's faster, cheaper, and simpler. And the reason I put it in triangle is because sometimes in a good architecture, you can achieve 2 out of 3. Either it's fast and cheap, or it's fast and simple, or it's simple and cheaper, but it's not fast, for example. If you get 3 out of 3, you're doing something very optimal. If you get 1 out of 3, you're missing the point. So essentially, what will make your BigQuery faster? We talked about partitions. We talked about architecture and a data model. We talked about orchestration. We talked about using Dataproc for ingestion and transformation and data pipelines. We talked about what would make your BigQuery cheaper if you consider partitions, if you use import and export, if you use quotas and maximum bytes build feature. What would make it simpler? If you use it all the way instead of using any other service, such as the streaming, such as Dataproc. BigQuery is a major centralized data lake, making the entire GCP very easy, affordable, and easy to get started. To wrap things up, in the end of the day, data engineering is all about faster, cheaper, simpler. Call to action, you're more than welcome to consider our Big Data Demystified website. It has all the past content in Hebrew and English. For example, you can go to GCP and get history lectures on different topics. You can go to Airflow if you're interested, and you have many use cases, blogs, examples, how-tos, both in Hebrew and in English. And we are more than happy if you can subscribe to our Big Data Demystified YouTube channel. It's a channel dedicated for you guys. So we will be honored if you just simply subscribe and like channels, the content we upload. This is me. This is my personal phone, our meetups, and YouTube channels. This group is essentially an international one, but we have in Israel the equivalent groups in Hebrew, and we have across Europe and the US the same group, only in English, because this is the languages I know how to speak, Hebrew and English. You're more than welcome to add me in LinkedIn, to contact me directly, to ask questions, so I can share with you content, perhaps give you an advice if you need some advice in specific areas. And I will be happy to get to know each and every one of you. It will be my genuine pleasure to speak with you, to lecture with you, to work with you guys. Now is the time to open your microphone and video if you like to ask some questions. Okay. I see there are no questions, not on the chat and not on voice. Okay. Should you have any questions, don't hesitate to send it to me. This lecture and slides and video will be uploaded in a few days to the Big Data Demystified website. And if you RSVP'd yes to this meetup, you will get the notification with the link. So you're more than welcome to attend to our next sessions. We have a few upcoming events which are interesting on different topics. We have about Alloxio, we have the introduction to SQL. So everything should be quite interesting. Okay, guys, if there are no questions, I will finish. There's a question. What kind of data do you use regularly in BigQuery? I mean, where did your data come from? Google Analytics or the sources? Yes. Good question. Google has several major platforms. GCP, Google Cloud Platform is one, but there's another one called GMP, Google Marketing Platform, which has many marketing tools which are all exporting the data to BigQuery. So this is the major use case. However, in the last few years, BigQuery has been heavily dominated around startup use cases which are growing from zero data to petascale relatively quick. And I highly recommend you check it out because in more than 50% of the use cases, it's going to be very relevant, very simple to get started, very easy to continue. You just need to be very cost conscious and cost aware, but essentially BigQuery can handle any type of data which is structured, semi-structured, and one of the benefits of analyzing semi-structured data that it can process new data without a schema. Meaning it can detect automatically the schema of your JSON, which is an advantage compared to other solutions. So everybody, thank you very much. It was a pleasure. I hope to see you all again in the next session. Today, thank you and good day.